allowed to reflect back out to the human eye. Look at it this way. Red, green, and blue all go into that scale. Red and green cancel themselves out, and blue comes out. The color that comes out, the wavelength that comes out, is based on the cell gap height. Nature's shown us a reflective color, bistable, zero power display. And what Qualcomm's done is we're mimicking it. We're building those same optical resonant cavities on a glass substrate with MEMS, micro electrical mechanical structures. And yes?
What about angular view?
Angle of view. So there's good angle of view, and before I leave here today, I'll show you a 5.7-inch XGA Mirasol.
You have one?
Yeah, active, live, running color, video, all that, and you can tell me what you think of the angle of view. If it's negative, you have to sit in the back. And so what we're able to do is, with the appropriate voltages, we can open and close that optical resonant cavity. And when it's open, light's allowed to enter and reflect back out to the human eye, and when it's closed, it's off. It's a display. And that's the beauty of this technology, is it literally uses the light that's around us. We don't have to generate the light. We don't have to filter the light. We use the light that's around us to generate the colors and the image, and that's what makes this technology so low power and so compelling. Power again. I'm going to hit you on the power one more time. A lot of technologies out there, but now when I talk about power, I want to tell you what it actually does in the e-reader device. Every technology, bistable reflective display technologies, consume power. It's a question of where they consume it. Now on this chart, it shows you some of the bistable reflective technologies that we compete with on a day-to-day basis. And it shows you, as you read a book, you'll read a book at about 2 pages a minute. Now when you change many of these displays, you update the screen, you start to consume power. And some of them consume power at a pretty high rate when you change a page. But at 2 pages a minute, reading a book, I read about a page 10 minutes. I don't get the 2 pages a minute. It starts to increase dramatically. Well, what happens when you go to magazines? The number of page turns increases, right? You're reading multiple pages a minute. What about panning, zooming, and scrolling? Each one of those activities represents a page turn. I even got to web browsing or full screen video. What the chart tells you is, as you move from just reading a black and white document as a book at 2 pages a minute, and you start to have lots of interaction with that device, the power consumption of these devices that are so-called low power end up being extremely high power, as high as maybe 10 watts on these charts. Boil it down, if we were to take an e-reader today, a typical e-reader, and put in all these display technologies, and not change anything, just make it for a dedicated reading device, which we wouldn't do, right? We want to have the color content, we want to have the video, we want panning, zooming, scrolling, all of that. But if we didn't do it on the first one, the Mirasol-enabled e-reader would give you 8.5 days of battery life. The competing technologies come down dramatically. But that's not the big story. The big story is on the next slide. Now what if we made that e-reader with color and video and panning and zooming and scrolling and all those interactive features that we want, the click-through for the ads, right? So they can read the magazine, click the ad, do the shopping, buy the product. What happens then? Wow, does their power consumption go off the chart. And remember when I talked about weekly charge cycles? With this type of a usage model, the Mirasol will last almost an entire week of 5 days. That's a pretty heavy usage model where not one of the other technologies enables an e-reader to go that far. Can you get them to go that far? Yeah, you put in a bigger battery, or you limit your usage of the device, or you leave it charged and plugged in. But remember that whole value chain, that whole food chain I went to, and how everyone's affected? Low power, here's another example. I'm going to meet that user's expectation, and I'm going to get him through the week, and he can use this device as he wants. I touched on this earlier, just an example of what it's like to look at a display inside versus outside. You have the EPD, which you've seen in the e-ink devices. It looks good indoors and outdoors. The Mirasol display looks good in indoor, outdoor, overcast. And this is an example of a TFT, which you've seen in your handset, where it's darn hard to see on a bright sunny day. Easy to see inside, tough to see inside. Value of color. I think this group recognizes the value of color. Yes?
How many colors now Mirasol?
That's a very good question. So I'm going to give you 30 seconds on that as I click through these. And I think we all get the power of video rate capability. On colors, we get this question a lot. For reflective bistable technologies, one of their challenges, how can you get vibrant, deep color depth? And so the first thing I want to talk about is let's take the speckmanship out of this, right? As we talk about LCDs or OLEDs, many times we'll talk about, well, we can do 256,000 colors. You've heard that many times, right? Well, the display actually doesn't do that. The driver chip, that's the spec of the driver chip's capability. It doesn't mean that's actually what you're seeing in the device. It's somewhat of a ruse. What you need to look at is what is the contrast of the display and the resulting color depth across a variety of ambient environments. I can get some great color depth numbers in a completely dark room with an LCD or an OLED. Off the chart, look beautiful. But do you use that in a completely dark room? You don't. You use it in this room. You use it outside. And as soon as you do that, their actual perceivable color depth comes down dramatically. So what Qualcomm's done is we've actually come up with some new standards which are called mobile color depth, which is what is the actual color depth the user gets in the variety of ambient environments that they live within. Okay? So if you were to look at our display, the XGA that I'm going to show you in a couple of minutes, I think that it's the perceivable color depth based on JND, just noticeable differences, is well over the 40 and approaching the 75,000 colors. But I want you to look at it and tell me what you believe the perceivable color depth is. I could bore you with the spec of the drivers and all that, but it's not really what the human eye sees based on the ambient environment that you're sitting in. That's important. Thanks for asking that question. The rest of you probably aren't so happy that he asked it, but so the summary is, and I'll get to the summary, is your challenge is to provide an enhanced user experience via various devices and display formats. At the beginning, I said there's a billion new Gutenbergs, 2 inches to 100 inches. That's your challenge. How do you make this stuff look good in all those different environments, those different sizes and resolutions? I think it's, I encourage you to step forward and look at the technologies to make that happen and reach across to the technology part of the world. Because when you do that and you make this thing just look better on the display, it also just naturally takes you into, you're the one managing the subscriptions, and you're the one getting the metrics on who's reading and what they're reading, and you're the one managing where they're clicking on what ads and what not ads. It's just a natural progression which unlocks the revenue of your businesses. So I think before I go, if you want to see one of these devices, you're welcome to come up here after I'm done talking. And I want to leave you with one last thought is, I appreciate your time today. Do take a look at this if you can. It is a 5.7-inch XGA Mirasol display running active, color, video rate content like magazines and newspapers. It's low power, and don't take my word for it. I think there's been over 9 technology awards for the Mirasol technology. And I would have that screen come up, and there it is. Over 9 awards now for this technology that you'll see, by the way, because this is the next question. New technology, wow, when are we going to get it? Before the end of this year, this technology will be e-reader devices. That's it.